Hey everybody, quantlabs.net. Just wanted to show you among the umpteenth architecture of this system, but specifically what we're talking about here is what I call the position manager. And this is probably one of the more difficult parts or components of this upcoming system. This is the architecture I'm looking at with the previous videos over the last few days that I've looked at. The first one is this one, which basically, as it loads, this video, I've already had a couple of questions concerning Redis versus SQLite. I'm now using Xcode with C++. If I get a suggested library that doesn't work or can be built within my Mac OS environment, I trash it and move on to the next. That's why I'm moving on to this stack that I'm about to show you. SQLite works. It compiles in my Xcode, it compiles, and I can work with it within my Mac environment for C++. The problem with Redis is basically that Redis C++ support for any platform operating system, it sucks. It's not kept up to date except for High Redis, which is in C, and with C++, they just don't really play nice together, especially in a multi-threaded environment. So as a result, for the time being, I'm probably looking at not using Redis at all in this whole environment. But I'm going to show you some of the alternatives that I'm slowly finding that may be better performance anyways if you use it the right way. So I know about SQLite, so this video here, the SQLite demo in C++, will show you how I interface with C++ interface with SQLite 3 in C++ in my Xcode, the IDE for Mac from Apple. Cool. That's number one. Number two is now I've looked at a lot of libraries, and a lot of them are pretty well over-engineered stuff that's not really worth looking at for a high-speed environment, for high-speed trading environment. There's just a lot of extra over-engineered, basically crap that you don't need. This video is just using raw sockets in C++ with Python, and I have the two communicating with each other. So this will lay down the messaging queuing for this system that I'm looking at, because this position manager is pretty well the nerve center for the whole operation of how this system will play out. This video is using raw sockets between Python and C++, just using the operating system. If you're using Windows, I think you should throw that away because of all the extra crap that Windows does, where all that extra operating system stuff is just competing for the threading that these type of systems need. So you want to be on a bare bones system, not Linux even. You want to be on BSD. When you install it, you basically are putting in or installing with a minimal environment. End of story. You can't argue that. So FreeBSD might be a good source to work from. Again, this is just all theoretical, but that's how I feel about this. So working with the Xcode is going to be 100% compliant and compatible with BSD, because, well, Mac OS 10 is built off of BSD, right? So again, that's why I'm using raw sockets. On top of, as I was mentioning, of the queuing and all this other so-called multi-threaded and heavy, very heavy weighted libraries, Kafka, RabbitMQ, they may work. The problem is they're written in like Scala and Erlang. Do you really want to bring those other, probably most likely unknown languages you know nothing about into your trading environment? I don't. That's just one more language I don't want to have to worry about to learn, right? There's enough on my plate to worry about. So that's why I throw away those kind of libraries, and a lot of them don't really work at all in Mac and when I compile it. So they say it's portable. It's not. If it's not able to build in Mac OS, then there's a problem because It's not 100% compatible, and it's may work in Linux, but again, with Windows versus Linux, that's fine, but you're still going to be having the same problem competing against those cycles where your Linux OS will have some competition happening. One thing I learned off the OpenHFT is you want to have all your operations off of the heap. So you want to be using level 1 and 2. One of the caches, anyways, I'm not going to get into it, but learn the OpenHFT to really understand how to properly do it. So there's that. So that brings me to you want to remove as many dependencies as possible, but at the same time, you're using SQLite for the right reasons, you're using Python for the right reasons, and you're using C++ for the right reasons. So the idea here is to have more smaller components in your system that are all interlinked with sockets as well as the databases, but the databases may not depend on one component versus another. So that's how I'm treating it. So what I'm doing is, the way I'm looking at it is, I have all my Python code to do some analysis of very simple stuff. I've heard about the performance problems when you start getting into trying to use Python as a complete language for for full-blown monolithic applications, especially for trading. I just don't see something I wouldn't go down, but again, I'm not fully versed in Python in a lot of ways for that. But that's why I use C++ because it's a proven language, and it works great. Anyways, so that's that. So we now come to as I always use, the ghetto approach to architectures. So what we're looking at here is we've got our C++ program right here. This one I just highlighted is basically, as I said, called the position manager. And what it entails is we got a number. This is now, remember, I'm going to be working with 3 strategies, and there's a derivative, a multitude of other strategies that come out of each asset class. So specifically, this is divided up by asset class. So for this case, it's paired trading and equity. I know that if I'm going to trade stocks and whatever, paired trading is what I'm looking at. On the outset with my new analytics service, what I'm looking at is using the paired trading just to watch the markets and just see what happens and trading opportunities open up in pairs. Okay. Because this can easily be used in any kind of equity, ETF, mutual fund, index, and direct stocks. That's not a big deal. Anyways, so as we say here, we are dealing with position manager. So before we get to this point, we have already, this is really important, and it needs to be made clear. Up to this point, where we come to the point we're about to have an idea presented to the position manager, we assume that we've done all kinds of analysis and we're now ready to take on a position. We're ready to enter into the market. So that's where this position manager takes hold and takes over to manage that position. So in our case with paired trading, what we're looking at is we're going to have a pair of stocks, let's say, for whatever, through the idea process, and we're now analyzed, we vetted it, blah, 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 and we know we want to put on this pair now, okay? Now, and originally when I looked at this, I was looking at doing only long-term position holds, like 30 days and 90 days. When I started looking at the markets, comparing between intraday versus long-term position holding, I thought to myself, why would I hold on a position, take on the risk for any kind of shock in the markets, and then that trading pair just goes down? It doesn't make sense to me, and the risk is not there. No different than the concept of day trading. You just don't want to hold off position overnight because it opens up for some unforeseen reason where that position with the pairs of stock may get hit on a negative, and you just can't forecast it. There's no way if there's a shock in a system, if it's news related or whatever. But we want to mitigate that risk. So what my view now is to start trading on an intraday high speed level. We're not talking HFT, okay, high frequency trading, but with this architecture, you can easily adapt it for HFT because it's in C++ with the Java plus the Python, okay? So it's very adaptable for that. But in this case, we're just going nice and easy. But the idea of this architecture that I'm looking at is to envision it one day, maybe 3, 5, 10 years from now, I may go to sub-second and maybe potentially HFT. I don't know, but this architecture will work, okay? So what we're doing is, as I said, we're going to feed in a pair, just Pepsi and Coke as an example. And we're going to maintain an array. And now we are needing to get live market data, okay? So in my case, if it's equity, obviously I'm going to get data from Interactive Brokers. Okay, that Interactive Brokers is most likely going to be fed in either via Java or C++. What I envisioned was to use IQ Feed, and I'm always going to use IQ Feed as long as I stay as a retail trader. That is no argument there, because the data is good and it's affordable. So the C++ with the Interactive Brokers or Java feeds it into this C++ position manager via sockets, okay? Again, I'm going to talk about where to go to get that video, the detail of that. So we're going to feed it via socket, via queue of message queue using sockets, and then feed it into this position manager. I'll break out what the C++ position manager does in a minute. So we have the market data being sent in. If it's being sent in from Java via IQ Feed, Interactive Brokers via Java or C++, we can do that. And we also, because now I'm an official client of Oanda for Forex data, and probably if I choose, like just riding off of waves of commodity trading for, let's say, oil, gold, some kind of metal or something that Oanda gives me access to. Again, we're just trading, like when I'm talking about Oanda, these are micro trading positions, like really tiny, like $10, $20, $100, whatever they cost, and it's very small. What we're trying to stress here is to ensure that we have bulletproof technology, and not only that, but our strategies work from the get-go, and we shake out all the problems that these systems that I'm working with will be proven by the time I upgrade to, let's say, Interactive Brokers, or maybe eventually if I go pure FX trading, Lmax. You ask me why Lmax? Well, it's simple, because Lmax gives me a much wider selection than these shitty brokers, retail Forex brokers, because their selection of currencies is really bad. And IB is a little better, but not much better. You want to go with Lmax because they offer you ruble, Turkish lira, the rand, really global but major currencies that are volatile. That's where you make your money, in those volatile currencies. But again, that's FX. Here we're talking about pair trading. So that's how it works. We feed in a market data, and we just have a little, in this case for pair trading, a little pair that we feed into this position manager. So what does the position manager do? Well, the position manager basically maintains an array of pairs, and then that will add that pair to a thread. Okay, so there's going to now be a new thread that will wake up and be created for this pair, for pair trading. So what the thread will do is every minute it will go out and check market data for both, whatever, let's say Pepsi and Coke. Every minute. I could break it down to sub-second if I want, with moving from bar data to tick data, but it's just a pure hell to do the conversion on the fly and blah blah blah. I just rather just keep it bare bones, simple, keep it to minute data, and that's it. So every minute that thread will wake up and do something, and what that thread will do is, it will, as I said, it'll check the market every minute, maintain a look back of a row, like a rolling window of data of prices for the pairs, and then it will calculate that rolling window of data of those pairs on their pricing ATR, because that's what I'm using for exit. So ATR is what I'm using to check for market condition. Now, I'll talk about something else about TBB, Intel threading building blocks in a minute. But after the ATR is checked, and let's say we have an ATR that allows an exit, we basically exit the market. So we take the position off, and we exit the market, and we unwind all the data that's set up for this particular pair, and and clean up the threading and all that. So before I go any further, I just want to give you some ideas about the detail of how all this stuff is done. There's two videos I just put up in the last few days. First one is SQLite demo in C++ for market data entry and exit potential. If you want to understand how this is done, all you got to do is come in here into my blog, and I've got the actual references that I'm using in the video for the source code. Okay, so you'll get that here. Okay, I think, but I think I explained all in SQLite. It's very simple stuff, nothing major. The other video is concerning the socket programming. So how it's done is very simple. This video explains it. And again, same concept. We have our blog. We have a blog that will basically talk about where to get the code. So the Python and the C++, all here. Dude, you can't get more brain stupid than that, or brain dead than that. Okay, so we got those. So let's talk about further or advancing the cause here with our little simple stack here. So a lot of people will now, obviously this is assuming with the threading and the messaging on the raw sockets, everything works out. But I do know, you know, that we have no guarantee that one component and the other component will get the messaging or guarantee of the delivery of that message. I already have a simple architecture that will basically defeat it, and the C++ code here the C++ code here will explain it all. And basically this is very simple, so I'm just going to talk about this. So here you'll notice here we have TCP socket samples, and we also have UDP socket samples. So each of the C++ needs to have these socket layers. But here, a couple of things. Threading with pthread. Okay, that's the pthread standard C++ library for multi-threading. Now, that will work in this example. Here, you'll see in the code, what it does is, here's the thread that gets opened up. So here, what it says is, so you get a thread echo server, spawns a new thread for each new client. So that's what we're talking here. So we get a market pair and we create a new thread right here. So we get a new pair, add a new thread, and that's what we're doing in this code, right in this coding example. Cool. But the problem is with pthread, it doesn't, I mean, it's standard. You're not going to get a lot of functionality with it. So I know that if I look at Intel TBB, which again will download, and I've talked about TBB, I can download this open source from Intel, be able to run it on my Mac in C++. Actually, they actually have Xcode examples ready to go. Brilliant. You know, that's the way true open source transportable project should work, not all this other trash that I see out there. All right. So again, let me also paraphrase something here. This is very important as well. One of the big takeaways I took away from the OpenHFT project is that a lot of guys like me always thought that Redis was the answer, Redis was the way to go. Redis is fine, but it's built on TCP/IP. So the socket programming here is built on TCP/IP. That's what I'm using. But if you see here as well, we are now using UDP. So if you watch some of the videos on HFT that I've mentioned years ago, and I've got verification from, we'll call him a mentor, who works at one of the biggest banks in Barclays, has hinted to me that you want to go UDP. So UDP is basically another protocol where you could take large chunks of memory and just through the magic of pointers, point your process to a new block of memory, just like that. So you can move literally like 2 gigs of memory to another reference and another process, be it in C++. You can do that in literally probably a second, and we're talking about gigs of memory. Okay, so if we go back into my example here where we are feeding into this C++ gigs of memory, okay, with the magic of C++, we are able to pretty in a wild way, we're able to basically move large chunks of data in memory using UDP. Okay, so I have this as an option. I still have to play with this and try to get it working in Mac, but I've had some difficulties. But I'm hoping to accomplish that. But I definitely have what I've shown in this video here, the TCP. This one I can get working, no problem. Okay, so those are the areas that I want to improve. TBB is great. I've got various videos on that. You may just want to go into my C++ library video playlist to look for those videos to see the capabilities of C++ and Redis. It's a very powerful multi-core library for C++. And as I said, I can get it working in Mac. All right, so we've talked a lot there. So we've got the threading done. We've got the envisioning of multi-threading at a deeper level. We also have the capabilities of not using TCP IP. We can hopefully move it into UDP as an example, and also move everything into TBB as well. All right, so I'm hoping to get that done. But I think once I go that route, I'm awesome. Okay, so the reason I'm really wanting to push TBB is for the specific reason of I'm already seeing a problem. Here you'll see I'm calculating a rolling window. It's no different than streaming data, which is how the real HFT guys do it, is they'll have in parallel algorithms analyzing that data and that stream or that rolling window of data. So the nice thing using TBB with C++ is we're able to use the TBB and have multiple in parallel algorithms to analyze that data. Okay, that's part of the visioning and rationale behind that. So it can have multiple algorithms in parallel analyzing this rolling window of data, which is basically pushing live data from my data source, my data provider, right? So here we are also including stop losses and stop targets. Really important because all the Nimrods out there, especially the retail traders, I don't know why they do this, but all the technical traders and all these dumbasses that use MetaTrader or whatnot to create a stop loss, and then I'm not saying stop losses are bad; you need them, but you send back a trade. You also send back your stop loss to the broker, which has what they call market makers that are just sitting there, kind of like barrel fishing, waiting for your orders to come in, manipulate, and well, in a way, have that trade kind of go against you or skim off the profit or whatever. I don't really care on your opinion on that, but that's a fact, Jack, okay? And that's what makes a clean broker and a bad broker. And a lot of these retail Forex brokers, I'm not saying Owanda's one of them, I don't think they are, but there's a lot of these brokers that go out of their way to make sure you lose in your trading. Again, you don't believe me, go to my channel. And let me just pull up a video here. You just do a search here. Let's do a search for 6 ways. There's this video here. This will explain how your retail broker will screw you.
What if I gave you
This is a fact. You can't escape it. This is how the brokers will lose. Will make you basically lose money in your trading, no matter who you're with. Okay, so let me just find, and I'll add that to my list. Really critical video that you understand that. Okay, so going back to that presentation, so understanding how that works. So part of that plan here, not just the ATR, but we're going to now trigger targets of stop losses and soft targets. Once again, people don't really use soft targets because soft targets are really critical. Again, this is the difference between the men and the boys that trade. This is coming from experienced hedge fund guys, millionaire guys. And I'm going to blow the lid off of these stupid morons out there that don't get this. The morons out there that lose money, that are part of that 90-90-90 club, 90% losing their money, 90% that lose, and 90% will lose it within 3 months. Those are the people I'm talking about. And they'll argue it down. I get that multiple times a day, and I don't care about these dumbasses. It's great that they exist because there's guys like me and people that follow what I'm about to tell you will make money because you use their liquidity to get out of the markets. It's their liquidity that enables you to get out of the trades, because once again I get people going, oh, look at this trade, man. I'm as the markets go up, well, you know, this is the time to get out. You have to take that famous contrarian view, okay, and start short and setting up your shorts before the markets at some point will tank. Okay, so knowing that, I'm going to do another more detailed video on it, but you have the stop loss and your soft target. So the idea here is part of, in this process that you have in your thread, as the equivalent in your strategy, being in this particular position manager, you can build a logic that will handle your stop loss and your target, your soft target. And what do I mean by that? The first rule is you do not send back your stop loss to tell your broker what you want your stop loss to be set at, because there's a market maker sitting there that are just waiting for dumb idiots to put those stop losses out there so they can fish and barrel fish those positions, skim off them, and basically even kind of like make sure that you are not going to get a profitable trade with that position. Don't believe me? Check out what Sanlucci says and all his crew on trading, chatting with traders. That's what they stand for, and they know that as a fact. All those guys pretty well talk about it, and it's a fact, and they're coming in from the insiders view on the HFT guys. That's what these guys do. So that's a fact. So what you need to do is you want to watch virtually your stop loss and your soft target. What you do with your soft target is you're going to say, let's say a certain maybe standard deviation over your stop loss that you're going to set at, and you're also going to use your stop loss dynamically. And there's a little formula you can use. I'm not going to tell you what it is, but it is commonly known on the insiders. And you set basically your stop loss in the range between 9 to 12%, right? That's usually what it works out to. So as your position goes down 9 to 12%, you don't even question it. You just get out of the trade. It's a bad trade, and you get out. You don't hold on to the trade. That's the first thing you do. When you see those positions going bad, take the 9% loss and get out. There's a lot of other ideas out there that are better for you. And that's the first thing to save yourself from being part of that 90-90-90 club. So that's how you cover the down if the markets go against you. Now, hopefully you've got proper analytics to work out the risks, what I call a risk assessment in the market conditions, to make sure you guarantee a higher probability of successful trades. There's numerous ways to go about when it comes to the position manager. For instance, if you know you have a trading idea, you could put out half a position. So if you got your system telling you to, like when you do the risk and reward management against your portfolio, which against measures your performance to protect your account and your basically your account, you can easily do that with Kelly criterion. And if you're in a winning trade or in a winning momentum like now, where the markets are just going up and you could throw money at it and still make money, your risk reward is, well, you know that your risk can be low, but your reward is going to be high no matter what you do. So you can add and increase your target and maybe have a higher level of your stop loss. Now, the other problem when you signal to your broker the stop loss, what you're telling your broker is no matter what, get me out of the trade if the markets are going up. Now, if you're setting it at, let's say, 9 or 12%, no matter what, if your trade in that position goes beyond that stop loss, you're now getting kicked out of the position. You don't have that problem when you have the virtual stop loss, right? It's because you're not signaling to your broker. But what you can do is you can have your system, and it can be done in this position manager, which is awesome. You can automatically on the fly have your stop loss and your soft target automatically be calculating on the fly to roll up the soft target and the stop loss if you want to run that position, if it continuously goes, it's profitable for a while, okay? So if you know that, you have that control. You can dynamically set your stop and your target, okay? And you can use the ATR as a measurement to get out. Now, at the same time, you could also feed it some more information if you really want to make it more complicated, maybe some more technicals and other things that you could use in parallel here in the parallel core as a way to measure your risk. So I'm not going to get into that yet, but I have that flexibility because I have this type of system that I'm developing. You don't get this kind of functionality with crappy black boxes. Guarantee it. This is why you've got to roll your own solution, because you have this kind of flexibility. It brings power. Okay, we've already talked about what you do on the downside. If you are going to hit your stop loss on the downside, you just don't ask. You just get out. Okay, so you could set this, what I'm talking about, with a dynamic stop loss and a dynamic soft target, and then be able to roll it up if you want, and have other metrics being calculated on the fly as the market data comes in, and be able to assess at the same time your risk and reward, and saying, well, the probability saying, you are running the position, but that position may not hold for maximum potential, so get out. There's a signal, then you exit the position. All right. Or you also could have a situation where you put on 100 shares of something, but you have like your metrics are saying no. You got upward momentum and the probability of it going even farther up. So you just keep adding to the position if your metrics are working in your favor, the market conditions that I'm talking about. But with this methodology, you have many options, and because you're doing it in C++, it's almost as guaranteed to maintain all that using a pretty well proven TBB multi-core library on top of a better database that can handle the volume as well. So the hindrance from a technical level is you better have a system that can handle multi-core as well as has a large set of RAM available as well as database, because everything's just hardware. but it's really the smart software architecture that gives you the power that you need, because everything else is just cheap. Memory's cheap, drive space is cheap, the kind of drives is not cheap if you go the flash memory or whatever other types of high-speed drives you want. But the real key behind it is this software architecture, all right? Because it's the multi-threading and the sockets that are the determinant here. So you want to strip away as much dependencies as possible, throw out all those garbage libraries for this type of architecture, because this is going to give you minimal coding, minimal number of things to do. The other thing that's really key is to ensure that your math on your entry, the math on your exit, really simple, because it's all about computer cycles. The fewer computer cycles involved to calculate something, the better. Okay, so it's all about scale and multi-core to enable you to do really well if you decide you want to go HFT. And I originally thought that Redis would be the one database that would handle it all, and it can. But again, learning from that open source, from that OpenHFT library, it really opened my eyes from all the videos I watched, and I would highly encourage you to watch the author Peter when he talks about all the different challenges you'll have when you get into this HFT level type of software architecture, because that's what it comes down to. So that's the idea here, but I'm kind of like going to build off of this. So as I said, we've got two videos that I've already highlighted here: the Python, C++ sockets, raw sockets I'm talking about, as well as the SQLite as well. Okay, so that's what's happening. Okay, so I don't want to get these kind of questions like what happens to your Redis, because it's all explained in this video. So I'm not sure if this guy watched it, but it's just another reason why I do these long ass videos to explain all this. So as I said, I'm getting out of this kind of idea, but I'm giving you the ideas. Don't ask me for the code, because you want the code, go elsewhere. But these are the ideas I'm coming up with, and they're just that, ideas. This could change again. I'm sure you're aware of it. But for now, this is the vision I'm going with. And I would also like to mention, if you do not know me, I've been taught by some very, very highly esteemed people. I'm going to mention that nobody I've not mentioned in many years, London Quant. I don't know if he watches this, but it's that kind of guy who makes things happen. Now let me go back to my video here just to talk about who I'm referring to. Okay, because this is the guy I've learned this stuff from, and I've modified it slightly. But if you want to do a search again on this guy, London Quant, I'll tell you, man, he's a man. You'll see all the videos that he's mentioned here. This one you may want to look up, Ernie Chan and London Quant, the Q&A. This is a really powerful video that you may want to watch, because this guy, London Quant, is probably, and I will say this with certainty, probably the most prolific, influential, most successful trader on the planet. Okay, I'm going to say that because his performance has been amazing over the year or a year and a bit that I've known him, and I've been blessed to get a peek in his mind. So part of this architecture that you're finding, there's little drib drabs of that here. Okay, so don't think that I'm some idiot that doesn't know how to do this, because when you get access to this kind of guy here, or Ernie Chan, I'm gonna be honest, I've got some really good people in my community, and this right here is it, because as I said, part of the key is keep your strategies and your math really simple, and the code to a minimum, and remove as many dependencies as possible and strip away a lot of the crap that I've seen. And lucky for me, being on Mac now, if it don't build on Mac, it's crap. And I've used that philosophy over the last week, and it's been a lot of pain for me to get to where I'm at today with these ideas. So I'm kind of, in a way, fought my way to get to this point and be able to be blessed with that. So it's a blessing in disguise. So using libraries like TBB and kind of SQLite in its own way to maintain the database, as well as the raw sockets, plus having my own little methodology to guarantee the delivery. I'm not yet talked about. I'm not sure if I will talk about it, but there is a way to do it, and it's so bloody easy. You don't need to spend millions of dollars on something like MQ series from IBM, because it's not that difficult. Okay, so I thought I'd put this out there, and we'll see how it goes over the next couple of days to weeks with all this, because this what we're looking at is the nerve center, and this will also do posting to my analytics service as well, because I know it can do it. And once I get past this, everything else is really just risk management and portfolio optimization on the weightings, on the positions, as well as the risk reward. And I've got lots of great ideas that come out of that. And this code as well can be somewhat versatile enough to be used in my futures, my options, and as I've already hinted at, the FX as well. So hopefully this video will help you out, and good luck. So don't ask for the source code, because there ain't gonna be any. All right. Other than that, talk to you later. If you want to dislike my video, if I was on camera, I'd be rolling out all my fingers to you and F you, because you're a troll, and there's gonna be, you're one of minority, and there's gonna be a lot more people getting value out of this. So don't think that you can stop me and hold me back, because you can't, because I know people out there don't like this sort of stuff, and I don't worry about it. And the people that take some value out of it, they shouldn't care either, because I ain't gonna stop. To say I won't stop, won't quit, screw you. All right, later, and hopefully this will work out just fine. Later, talk to you later.